From the campus of the University of Nebraska at Omaha, consider this with Kathy Wyatt, a program of issues and information behind today's news.
I don't want to have to be reminded who my husband is.
Or what I did for a living.
I don't want my kids explaining the numbers on the clock.
Or why I should change my clothes.
I don't want my daughter missing me while I'm still here.
We can fight for a future without Alzheimer's.
Hi everyone, I'm Kathy Wyatt. Welcome to the 28th season and this week's edition of Consider This. Our topic, the future of Alzheimer's care. Joining us to talk more about it is Dr. Howard Gendelman. Dr. Gendelman is the Margaret R. Larson Professor of Internal Medicine and Infectious Diseases, Chairman of the Department of Pharmacology and Experimental Neuroscience, and Director of the Center for Neurodegenerative Disorders at the University of Nebraska Medical Center. Thank you so much for being here, Doctor, and welcome, or should I say welcome back.
Yeah, thank you for having me again. It's really an honor.
You bet, thank you. I want to start with having you define Alzheimer's disease.
Alzheimer's disease is part of what we call a dementia complex. All dementias are not Alzheimer's and vice versa, but it's a progressive, what we call neurodegenerative disease. That means the nerve cells, the thinking cells, the connecting cells, the communication links of the brain begin to break down. And that includes what we call synapse, which are the abilities of these nerve cells to communicate one with another. So we start off, as you know, and we talked before, almost a year, maybe a little more than a year ago, that plaques, these plaques that are indicative of Alzheimer's, or early pathobiology, the early events, they accumulate in the second or third decade. So you can be 20, 30, or even 40 years old, and these plaques begin to accumulate. So there is a prodromal pathobiology or pathology that occurs. Now, the mainstay of all of this is not just getting plaques or accumulating these plaques in and around the nerve or the nerve cells is indicative of dementia or of cognitive impairment. So the big issue in defining Alzheimer's disease is what are the other factors. If the plaques accumulate very early, most people don't develop the signs and symptoms of dementia. What actually triggers the changes in cognitive behavior and motor impairments? And that's really the epicenter of where science is. What actually is going on inside the brain cells, the communication links, and how these plaques and ultimately tangles, which are different proteins that form irregularly, how do they lead to memory impairment? How do they lead to changes in behavior and movement? And that's really what scientists are trying to figure out and work on.
People often ask about this, especially the cause. You talk about these plaques, but is someone more prone to this, doctor, than somebody else? Or how do you communicate the causes to people?
Well, there are associations, I'll be honest. There are genetic links. There are specific genes that make people more prone to develop these types of symptoms, the memory impairment, and the recognition changes that occur with Alzheimer's disease. But it's a tough way to go. Why? Because we don't bring in patients and say, we're going to do these tests, we're going to do these genetic tests, and you may have a 4-fold, 8-fold, 10-fold greater chance of developing this disease. What are you going to do with that data? What are you going to do? What are you going to change? How's your lifestyle going to be modified if I go to you? I'm the doctor, you're the patient, and you have a 4, 5, 8, 10-fold greater chance. You may never develop the disease. You may develop the disease, or you may develop it in later parts of your life where other comorbidities may occur. So even with the diagnosis or the possibility of a diagnosis, we still don't know what to do with it in terms of telling patients, yes, you will not, or you have a differential chance of developing this disease.
When we talk about these people, What are we talking in terms of the number of individuals who are actually living with Alzheimer's in the United States?
Okay, we talked about this a year ago. So, and I know there was some back and forth because the millions that we talked about is kind of a quadrum. It's about patients that may have mild cognitive impairment. They may change because we don't know that the progression of this disease is the same for everyone. That's number one. Number two is we often disassociate this disease with other problems. People may be depressed, they may be on drugs, they may have suicidal problems and issues, they may have family inherent morbidities associated with depression. And it's sometimes very difficult to separate the signs and symptoms of Alzheimer's disease with the normal issues, problems, and comorbid infections or degenerative type disorders that are not associated but linked to Alzheimer's. So when a patient comes in, what are we concerned about? We're concerned about other diseases that can affect how people think, how people act, how people behave. So situational lifestyles, endocrine abnormalities or hypothyroidism, diabetes, weight change, issues of situational depression, all of those things can be associated one way or another with an inability to be cognitively perfect. So there is a very aggressive workup when a patient comes in to discern other forms of dementia, other metabolic changes, other endocrine, other degenerative disorders, things that people have commonly that could be masks or could confuse an individual or a doctor or someone caring for that person with Alzheimer's disease. And it's not, something that we do a blood test and we say, yes, this is what you have. The other problem or an issue that we face in the clinic is that the most common part of the disease is age. So advancing age is the major comorbid factor that predisposes individuals to develop cognitive abnormalities and disorders. So people say, well, I'm 82 years old, and I don't think as well as I used to, and my memory is a little affected, and my wife was sick maybe a couple of years ago, and I'm dealing with a situational problem, and I've become more forgetful. How do you discern, how do you separate those types of life events with what we call Alzheimer's or other forms of dementia? So it's not a one-shot-fits-all.
Yeah.
It's a more complicated set of diagnoses that we have to work through. And obviously, if the signs and symptoms are rapidly progressive, if the cognitive impairment takes a major part of the complex, and the behavioral changes that are coincident with that occur relatively rapidly, the diagnosis becomes more easy or easy to make.
So given everything that you have just said and the denial that people often face with this, because it is so very scary and it is so progressive, for the viewers watching, if anybody's watching thinking, I've been meaning to get my loved one in, at what point would you seek, based on everything you've just said, at what point does an individual, a couple, a family actually go in and seek medical advice then?
Well, I think there's a couple parts of this that, that kind of are an impetus or a drive to seek medical help and intervention. And it's not just not remembering where you put the car keys, or whether the dishes need to be done, or whether you were going out for a trip or dinner with family. But these are progressive cognitive changes that occur in a relatively short period of time. So if an individual goes from being what we call mildly forgetful to not recognizing people, events, times, and there's a progressive change in their abilities to think through issues, recognize people, recognize events, calendars, just simple mathematical calculations and issues, recognitions of things that would be a normal part of their daily lifestyle. And that occurs relatively quickly. Now, we're not talking about years now, we're talking about days to weeks. That would be imperative, I think, for that individual to seek medical attention and try to define what the cause of those changes are. And not all of them, those signs that we talked about, the forgetfulness and the changes and recognition, are going to be Alzheimer's disease. Some of them, a fair number, are treatable. So it is worthwhile to let the readers, I said the reviewers, or people who are watching this show, not just reading books about Alzheimer's disease, but actually thinking about their loved ones and their significant others that are affected, and when, how, where, and what they're going to seek medical attention. But it has to be progressive, it has to be different, and it has to occur over a relatively shorter period of time when we do become nervous and disturbed about changes in people that are very close to us.
We're going to talk about treatments in a minute, but I do, as long as we're going down this path, I want to talk about the absolute importance of early detection. So again, there are people who are going to wait a little bit longer. Fear drives a lot of that, and uncertainty, right? Talk, please, about the importance of early detection.
Okay, so we're in the middle of a revolution. I'm going to be really honest with you, because Alzheimer's disease for a very long period of time is, even when a diagnosis was made, you come in, you see a doctor, the behavioral tests, the motor tests, the functional tests are done, diagnosis is shared, and you say, well, there's really nothing we can do. You can take the key and you can throw it away, you can support, but it's a very depressing, difficult diagnosis, and it's very progressive. But we're living in a revolution, and I think that's the reason that I'm back in a year, because science is going at a very rapid pace, and early diagnosis is becoming ever more important. So what do I mean by that? What do I mean by ever more important? Well, for the most part, we said, well, if this is a diagnosis or a concern, a doctor would come in, he would examine the patient, he would do the normal behavior and cognitive tests, and he or she, I should say, doesn't necessarily be one or another, would make a putative diagnosis. And they'd say, okay, you need to diet and exercise, you need to be in a good lifestyle, supportive environment, free of stress, depression, and we'll go ahead and do all these other metabolic tests, make sure that your thyroid function is normal, your liver function is normal, you're not drinking excessive alcohol, glucose measurements, so there's no worry about diabetes or any other metabolic disorder. And after those are kind of ruled out, there would be a brain scan, or what we call a CT or MRI, to make sure there's not a mass or a tumor or any other related disorder. And it would be all supportive. You know, we would make that individual happy, lifestyle, supportive environment. But there wasn't really much to offer those people. But I just said at the outset, things are starting to change. We do have medicines that can actually affect early, not all Alzheimer's disease syndromes, but some that can actually slow the progression. And in some ways, some of the newer medicines even reverse some of the cognitive impairments. Now, I know you're getting to this, but I'm going to usurp you in this if I can. But the University of Nebraska Medical Center is taking a big lead in this. So I do want to talk a little bit about what's going on 2 blocks from here, or a mile from here, if I can.
Absolutely.
And then we did start a year ago, but we're going to kind of develop this. So just a couple things I want to share, and then we can kind of go from there
Sure.
and start. So I said that the signs and symptoms of what we call plaque formation, these are extracellular misaggregated proteins that kind of clump in the brain and accumulate. They happen to the majority of people in their 20s, 30s, 40s, relatively early. Does that mean the people who develop these plaques, these accumulations of proteins, it's kind of a constipation of the brain, so to speak, will they go on to develop Alzheimer's disease? The answer is no. Some of them will, and some of them won't. But the people who have it, it is and develop signs and symptoms. It's a harbinger of beginnings of other changes. So what happened in the beginning in science or scientific discoveries is to develop what we call antibodies, some immunological approach that will clear these plaques. And that was the big praise about 20 years ago. Major push. Develop antibodies. The antibodies would target these plaques. They would disseminate throughout the brain. We would develop a way to get them through the blood-brain barrier, and there would be a decrease, a big decrease in the numbers and the extent of these plaques, the plaque formation. But we found that that didn't work. It was ineffective. There was clearance, but the signs and symptoms had only a marginal improvement or no improvement at all. So we had to go a step further. And I think that's what we started with a year ago. And the advances are what we're going to talk about now.
So this new cellular therapy. So for viewers who didn't see the program previously, briefly tell us what that is, and then we're going to drill down and talk about how you're able to get to where you are.
Yeah. And we've made a lot of progress even in the year, but let me try to cover this as best I can. So the first part of the treatment, right now, it's combinatorial treatment. So the major focus up until a year ago was to clear the plaques and affect some of the inflammatory effects of that accumulation, because there's inflammation and there's plaque formation. The effect, or the positive effect, on people's well-being, which we call the dementia, the severity of the dementia, were modest. So the big change in what we were thinking about the cellular therapy, because the cellular therapy was still designed even a year ago as a clearance mechanism, kind of a vacuum cleaner of the brain. And some of these drugs have been approved. They're already out there. Patients are getting these medicines, they're antibodies, and there is some modest improvement, not phenomenal, but some modest improvement. But we knew that we had to take this a step further. So what do we mean by a step further? Well, a step further is not simply to clear the plaques, but actually change the way the brain is functioning. Now, how can we do that? How can we do that with cellular therapy to change the way the brain is functioning? I told you even a year ago, we were still geared towards going after these accumulated of misfolded proteins that a lot of people get and are predisposed to cognitive changes indicative of Alzheimer's disease. But the big change is, how can we use this cellular therapy and make the brain more functional? How's that going to happen? So we had to do three things, which we've achieved in the last year. And that study that was shown was the first stage of this. We had to change how the cell thinks. So we talked about the idea of taking a cell and making it behave like a dog, respond to certain stimuli, but that wasn't enough. We had to find a cell in the body, and this is our big quest, that there is a cell in the body that's reparative. And we talked briefly about cut or scrape, and the body defense reacts to that. There's inflammation, there's swelling, there's redness, and then there's clearance. But less than 1% of the cells that we have, they're called white cells in our body, are reparative. And even less than that 1% could repair damage in the brain and make people think better. So how are we going to find a needle in a haystack? How are we going to find that cell that could repair the damage that's operative in Alzheimer's disease? How can we do that? Well, the first thing was to discover what cell actually was capable of brain repair. And we worked for many years, actually decades, to sort out what cell did what, how it did it, and when it did it. And after nearly 20 years of research, and I'm talking about 15, 20-hour days, we were able to find that cell. But that was just the first step. It was just the first step. The second step was to purify that cell. Because if you're looking for a needle in a haystack, you have to be able to take that rare cell and generate many of those cells, many of those cells. And that also took using columns and size, all kinds of molecular and biochemical techniques to make one cell 5,000 cells, 10,000 cells, and purify that. But even if we were successful, and we still didn't have enough of these cells that would repair this damage that had occurred in progressive Alzheimer's disease. So we did something very ingenious, and we started that a year ago, and we've made huge strides. And I'm going to try to explain it in very simple terms, but you can see, because I'm very animated, that we're very excited about this, super excited about this. So let me try to do this, and you can just pinch me and tell me, much too complicated, Dr. Gandelman, you got to slow down.
Well, you have quite a trick here. You have about 3 minutes to do this very complicated explanation to simplify. So you,
I got 3 minutes left.
It's your challenge. We have several minutes left, but let's start there.
Okay, I'm going to do my best.
All right.
Okay, so I give you an immunization. Let's say polio, mumps, rubella, tetanus, whatever, that you come to a doctor, and you generate an immune reaction of an increase in cells. Let's say I take that cell that we discovered, and rather than reacting to polio or mumps, rubella, and even COVID or whatever, and now we engineer the cell using molecular technology, fancy technology, to only recognize the cause of Alzheimer's disease, the protein that causes Alzheimer's disease. So we take that cell, we go inside the cell, we dissect that cell, and then we make that cell respond only to the cause of Alzheimer's disease. So every time that cell sees the protein that's causing Alzheimer's disease, what will happen? It will grow, it will proliferate, it will divide. So the next question was, okay, that's great and wonderful, Dr. Gandelman, but how can we make that reparative cell divide and actually induce repair in the regions of the brain that are cognitively impaired where the person has developed dementia? How do we do that? So we developed technologies now, which we're very, very excited about, that can transiently affect how the barrier between the blood and the brain are changed. So we can open it up transiently, this blood-brain barrier, can get these cells to go across that barrier, and then, because they only recognize the cause of Alzheimer's disease, they'll begin to grow. They'll begin to divide. And the more these proteins are present, the more divisions of these cells, the more and more, it's like an army of cells growing and growing and growing and growing. And while they grow, they're positively attacking the cause of Alzheimer's disease and clearing this. Now, what we're super excited about, which I share with you, these new animal models that we've developed that are what we call humanized, which have take a human immune system, yet they're a mouse. But what these mice do that no other mice can ever do before them is we've also genetically engineered these mice to have the causes of Alzheimer's disease. So these mice, for the first time, will develop a replicate of human Alzheimer's disease. Never happened before. And we were able to do this right here at the University of Nebraska Medical Center. Super exciting, super exciting. But what's even more exciting is now we have the opportunity for the first time in a mouse that does have Alzheimer's disease and does have a human immune system that we can then treat these mice and see if we can make Alzheimer's disease go away. We get these cells, they go and attack that area of the brain, they clear the plaques, they help the intracellular communication links, they repair the memory, and we can do cognitive testing on these mice. And the really very exciting work, none of this has been published yet, but will be very soon, is the reversal. The beginning to reverse the signs and symptoms of Alzheimer's disease. I realize it's a mouse, and we haven't done this yet in humans, but we want to do this as quickly as we can. We're working day and night, and the idea that we can repair the communication links, clear the plaques, and have a nidus of response where these cells will, in fact, grow in the presence of these Alzheimer's proteins and reverse these signs and symptoms, gives us hope, which is a capital H, which is a four-letter word, H-O-P-E, by the way, but it's a good four-letter word, that we can actually have that opportunity to perhaps do something really important and spectacular in this research. So I guess I had the 3 minutes.
You did. No,
Am I
you
okay?
did really, really well. We're talking with Dr. Howard Gendelman today about the future of Alzheimer's care, and I can already tell we're going to need to bring you back as all of this moves forward. You have about 15 seconds. I want you to talk to people out there who are on the edge of their seats, who know somebody, either they themselves, or they know someone with Alzheimer's. In about 15 seconds, give them some hope.
Okay. So why am I here? Why am I here? I mean, I was here a year ago. I'm here just for one reason, and that reason is one word, which is hope.
All right.
And we're living in a time where that word is not a dream, it's a functional reality.
Thank you, Dr. Gendelman, for joining us. We wish you the very best, and we will look forward to those updates. Our students working so hard behind the scenes, and all of you for watching. We'll see you next week.
Consider This is an issues and information program produced by UNO Television in the School of Communication. More information and program archives can be found at nebraskapublicmedia.org/considerthis. If you'd like to share your comments about this program, call the UNO School of Communication at 402-554-2600 during regular business hours, or send an email to consider.this@unomaha.edu.